Good morning, everyone. My name is Sudhanshu Jain. I am part of VMware's product management team, which focus on server platform, core stack, networking, and storage. And that is my responsibility from the VMware side on product management. Today, we are going to talk about NVMe in virtualized world. First of all, VMware is all about virtualization, whether it's a compute virtualization, storage, networking. We do pretty good job on that one. So we'll talk about that. A small disclaimer, some of the information which I'm sharing is advanced information. Please do not take that as any commitment, what we are taking it, making it here, that we are going to deliver it as part of product. But definitely something which we are working on, and which, if you're interested, feel free to reach out to me. I'll be more than happy to talk about and go in more detail if needed. This is the NVMe Express sponsored session, and it's all about NVMe drives, NVMe protocol, but operating systems and ecosystem on the software side is also very important. And at VMware, we are looking into the NVMe ecosystem from the software perspective, and we do see there are a lot of challenges we need to address, and that's what I'm going to talk about first. That NVMe challenges to software and its evolution. I think this is something I'm looking at from VMware perspective, but I'm sure, and there's a lot of work need to be done, or people are already working on, whether it's a storage array vendors to address from the software perspective, or whether it's any operating system, or in our case, hypervisor perspective as well. And these challenges are pretty significant, and we are taking those challenges and we are trying to address that. But before that, I think just wanted to, this is something which I took it from SNIA website. Earlier, this is the sort of a journey when what the hardware storage media has gone through over a span of time. I think at one time, hard drive was having maximum latency, but slowly hardware catch up and software got exposed in terms of the latencies which are able to come from the software side. At this time, I do see that especially when you talk about NVMe or Optane memory from Intel, my esteemed colleagues, they're pretty fast. That the hardware is no more a bottleneck. Most of the bottlenecks are coming from the software side, and that is a challenge for us as a VMware to address that. So we are trying to take up that challenge and trying to see how we can address that. And if I want to summarize, I think there are a few challenges on NVMe front, on the parallel execution as well as the performance front, because majority of the stacks are serialized today. They are not optimized. The file systems are not optimized for concurrent operation. And also the media is so fast now. We are seeing the NUMA challenges also exposed. Earlier, it was like nobody even bothered to discuss that topic. But now, both from the media perspective as well as from the networking perspective, it's so fast. You're catching up the bus bandwidth now in terms of networking as well as from media perspective. So now the NUMA challenges are becoming challenging, a issue also for us to address. How do we make NUMA awareness for applications, especially certain performance-sensitive application, telco world, or for that matter, in AI/ML as well. If you're eating up that much bandwidth, and if you're going over the NUMA bus, it's going to make big difference in your performance. I/O scheduling, resource management is always a challenge, and when you're working at a hypervisor layer, when you're going to do resource scheduling for multiple operating system on top of you, that's also a very big challenge. We are trying to, and why I'm highlighting here, because NVMe is exposing all those challenges. That's where we are coming from, because NVMe is so fast, it's so good, thanks to all the SSD vendors and hardware vendors on that front. Performance perspective, we are looking into it, all aspect, IOP operation, how do we address that? Overheads on IO front, queuing, you can add more and more queuing. You already have so many queuing in NVMe front, but that queuing adds up the latency, and that latency is a challenge from certain application perspective. And then, when we're talking about hypervisor specifically, then there are multiple worlds. There's the virtualized world, There's a core stack world, there's a hardware world. Everywhere there's NVMe or parallelization, and all that has to happen in concurrency. How do you make that? And that's a big challenge. I think everybody in the software side of world should be thinking about it and addressing it. And we at VMware also looking into it and trying to address that. Just a pictorial view. I think typical storage stack, you have file system, you have storage, block storage stack, and then your drivers, you have schedulers, you have certain application. You can have application or you can have guest operating system. They can have their own stack on top of it. But that's what the typical stack is, but it's pretty much serialized. Now, serial means there's a very a small throat to choke at this time. That's what the typical architecture is when you go in the SCSI world. And that's something is a challenge. I think that limits the IOPS. No matter what you do, you can do as many magic with your thread management and scheduler, but it's still a big challenge. And with the NVMe, you get a lot of queues, and those queues need to be handled. And if you want to take advantage, you need to build more and more queues and more processing. But that's not working out very well because you can do up to certain point and patch that work on a SCSI world, and that's where we are right now. I think where the market need to move or the software architecture need to move is a ground up NVMe stack. I think that's where we need to build that, and that is basically need to be at the driver layer, need to be at core stack level, they need to be at the virtual device level, need to be at guest operating system level. Everywhere you should be able to talk NVMe lingo. I think that's something, if you don't do that, you will not be able to optimize your stack. I think that's where we are coming from. In addition to that, I think, persistent memory is also coming into the play, and that also is going to be an area where you need to handle the storage aspect of it. And there will be certain use cases, maybe not mainstream, but certain use cases you'll be handling it at persistent storage level, and which means byte addressable, load store semantics, but it's more targeted for the storage use cases, not just for application perspective. I think that's the area where block storage and bytes addressable both NVMe will be playing in, and that's the area where we want to evolve our stack definitely from architecture perspective. We want to continue support SCSI. It's not going away anytime soon. Hard drives are maybe not going away as well. Tape drives aren't going away anytime soon either. So that's going to be there, SCSI stack. NVMe is, I think, the future. A lot of innovation, a lot of investment will be happening in NVMe front. But in certain use cases, especially when we talk about very performance sensitive, there is a space for persistent memory-based storage as well, both in block world as well as byte world addressability. So if you see this picture, you can think of NVMe as a replacement for SCSI. I think that's what I'm projecting it here. I think from architecture perspective, when we're looking at NVMe, we're looking at both local NVMe as well as NVMe Fabric, and that has to be evolved as well. We are looking and trying to architect the NVMe stack in such a way that it can support any transport. Of course, it will support PCI, it will support a Fabric with fiber channel, RDMA, TCP/IP, and for that matter, it can be supporting it in future something else like CXL. Also, we may do NVMe over anything, pretty much. That's where we are coming from, and that's architecture we want to build. And in fact, this is something is not what we are thinking only. We are doing it, and it's a plan of record. We are working on it. If you're interested to do some as a customer or as a partner, some proof of concept with us, it's available today. So if you're interested, please reach out to me, and we'd like to work with you on all this aspect which I'm just talking about. I think NVMe Fabric, I will say, is a pretty significant step for overall storage industry. You might have heard about computer storage. You might have heard about NVMe as a transport, not just for storage, but anything, pretty much. I think that's a very big step where NVMe can play a bigger role. We think NVMe over Fabric is a fundamental shift as far as technology goes. How you will be consuming storage, how you'll be consuming, how you'll be interacting with multiple resources in the infrastructure. Let's put it that way. Whether I don't know whether you heard about it. NVIDIA announced something, GPU directly talking to NVMe now on NVMe Fabric. So those are area where NVMe will be the de facto transport semantics or protocol, whatever you name it, will be used as well. So I think from that perspective, we are fully committed to this technology, and we think it has multiple use cases. A lot of people are talking about storage arrays. Of course, there will be many players. If you come to VMware 2 weeks down the line, there will be a lot of players, storage worlds, traditional storage world, will be showing early proof of concept with us around that technology. But beyond that, there are many other use cases. We do see, especially when you talk about SCI, hyperconverged, there's a use case around how to grow compute and storage independently in SCI world. Although it's a misnomer, saying SCI on one hand and saying grow and compute and storage independently, but that's a real problem our customers are looking into, are seeing it, and we need to address that. And we are looking into that and trying to address those concerns for the customers as well. Beyond that, I talk about NVMe drives or NVMe arrays or NVMe BOFs, JBOFs, becoming intelligent and doing not just storage aspect, but some computational aspect also. Maybe accelerating databases. And there are a lot of work going on in that space as well. How do you accelerate application with some hardware assistance? And there are tons of approach around that. Computational storage is one aspect, and then people are already doing a lot of FPGA-driven approach where the storage and computational aspect are married together. I think that's where also NVMe Fabric will play a bigger role, in my opinion as well. Composability of your rack, composability of your chassis, composability of your, the whole pod is another aspect where VMware are very seriously looking into that as well and trying to see how do we make and address that challenges. I think NVMe will be in multiple aspect, multiple transport, and I think everyone will have his own space and every use cases. It's not one versus other, in my opinion, because if you talk about traditional storage, I think Fiber Channel will be there for at least foreseeable future, and NVMe Fiber Channel will be available. And beyond that, I think RDMA and TCP/IP both have their own merits, and they will be there as well for different use cases. And we want to make sure that we support all the varied need. From our point of view, VMware is sort of a platform play where we want to make sure you bring your application, and we want to make sure that we provide best of the breed solution from the whole ecosystem. And that's our approach is around that as well. But NVMe has a lot of, area where we need to grow as a software I'm talking about. The management aspect is big challenge. How do you collect the statistics? How do you make use of those statistics? Intelligent decision around that. Intelligent optimization of your based on application. We had a lot of talk around GNS and all that stuff here, IoT. All that stuff is very interesting. I think that's the area where we continue to innovate and evolve. Serviceability is another aspect because, these medias are becoming pretty huge. Each device could be multiple terabytes. And they will be failing. And once they fail, there will be a lot of impact to your infrastructure once it happens. How do you do in-service updates? How do you make them more higher endurance, not just from hardware perspective, but also from software usability perspective? I think all that aspect, we at VMware are also looking into it and trying to address. Of course, not going to be one release journey. We want to make sure that we work with broader ecosystem and try to address all those challenges. And the call, if you're interested, feel free to reach out to me, and we'd like to work with you guys on all the aspects, whether it's performance, whether it's serviceability, whether it's management, whether it's composability. All that I think is very, very interesting topic for us in general, because for us, we have server platform, and that's a big play itself, where server attached storage is becoming a phenomenon of its own. whether it's for SCI use case, whether it's a big data use cases, whether it's there are many other areas where we are getting a lot of virtual appliances who are using their own local storage because they are so intelligent. They don't need enterprise class storage of its own for them to be managed. So we are looking into it, and we are trying to address and love to work with the whole community here. When it comes to VMware, I think, let me just build it. I think we have been working on it. There are 3 different swim lane, I call it, and that is how we are architecting driver layer, core stack, and virtual devices. I think 6.7 is already out. We have pretty good growth of NVMe attach, both from server side as well as from the SCI or vSAN perspective, and we are seeing a pretty good growth on NVMe front. I think going forward, as I said earlier, we are going towards all NVMe stack. That's a big investment. Re-architecting the driver to make sure that it works not just for local PCI transport, but also work with multiple transport. And we want to make it as easy to plug in any transport as possible itself. NVMe Fabric is part of that strategy. Serviceability, also we talk about that. Multipath is, once you get to the Fabric, the multipath is a big part of the puzzle as well. In fact, now with the dual port devices, multipath is also important even for local NVMe devices, and we are trying to address that as well as we go forward. On virtual devices, we already support virtual NVMe device, which is a device simulation. What it means is pretty much any native NVMe driver in any operating system should work just fine. And we work with Windows and almost every Linux distro NVMe driver with our device simulation, and it just works fine. And it's a lot more performant than our traditional PV SCSI layer, and we are trying to improve upon that. And in fact, there are a lot of roadmap on that front as well to improve the overall performance of our device simulation to give best of the breed solution. So I think that's the way it is. And just to give a high level, it's pretty complex. We have all sorts of possibilities and what you call the nuts and bolts we provide to our customers, our operating system vendors, and our application vendors in terms of the overall stack, both for networking front and storage front. So basically, if you see it, we have TCP stack and SCSI stack, and in fact, we have multiple options. You have options for if you want to bring a device and you want to just bypass complete hypervisor, you can do that, although it's not the best of the solution for us. But a lot of vendors, if you go to many third-party hyperconverged vendors, that's what they do. But it works fine, and they use our platform for doing that part. Then we also support SRV. SRV is pretty device agnostic as far as technology goes, and you can bring any technology, whether it's storage, networking, GPUs, or FPGAs, as long as they are SRV or any accelerator, as long as they are SRV compliant, that should work just fine. In fact, we have certification around that as well, and you can use our certification to do a device agnostic certification of your SRV model only. And beyond that, you as IO vendor, if you want to certify and get to the market, you can go, and we will support it from the device SRV perspective, and beyond that, you support your customer directly on, let's say, InfiniBand. So InfiniBand, if you want to support, you can support as a SRV model on that. On virtual device, we have device simulation, like a virtual NVMe device. In that mode, we adhere to a particular spec. For example, today, on NVMe front, we are adhering to 1.0e spec for virtual device simulation, and we want to go to beyond that. I think 1.3 is target in future. We'll like to go. But we also have para-virtualized device, which is optimized in certain way, and that basically that gives a area where you can improve on top of it, and we do certain optimization which is proprietary, but the overhead is that we have to maintain a driver, whether it's PV driver for PV SCSI driver for Windows or PV SCSI driver for Linux. We do that, and actually and we do it for networking, we do it for PV SCSI, and as well as for other virtual devices as well. So that's the area. I think the overall, I will say that storage is an evolution path, and NVMe is changing the status quo, and we are basically trying to make that happen along with our ecosystem player. So NVMe is the area where we are saying it a parallel stack, and we are working on that. I think overall, I will say we have been working with NVMe Forum and the broader ecosystem. We have our own driver, which is PCI driver. It's open source and it's available if you want to innovate. And we also have a broader ecosystem of about across the board. Any drive manufacturer has certified. Almost everybody has certified with us today. But beyond that, we are making investment in NVMe Fabric, and early proof of concepts are available today. If you want to do it, please work with us. So NVMe ecosystem is healthy, and we are integral part of it, and we will continue to be integral part of it, and we will continue to invest in that area as well. And thank you, NVMe West Forum, for all the support and leadership on that front. So the key takeaway, I think, is there's nothing much to say here. The future is here. I think we do see on vSAN front, if you ask the vSAN team, NVMe is the number one priority because they see a lot of advantage with vSAN. For example, they are able to deploy even a very, very mission critical workloads on NVMe platform with vSAN architecture, and that's possible because of the NVMe. I think NVMe is challenging almost every status quo in the storage side. Server storage, operating system, hypervisor, DAS model, almost DAS is an NVMe Fabric can give you pretty much the same performance and same model, but not to block your data into or pigeonhole your data into one particular server. That's an area where the DAS is, NVMe Fabric is playing. SAN, almost every SAN vendor you talk, they are moving to NVMe. And if they are not moving, I think they are not doing the right thing. That's my take. I think software, as I said earlier, has a lot to catch up, and will continue to invest in that area. Ultimately, the application vendors, the customers are the winner, and this is a great technology which has been happening for some years, and I think prime time is now, and we are ready to help our customers and application vendors. Thank you.
So Suds has been gracious enough to let me borrow his slide that says questions for the next 5 minutes. Yes, please come and ask questions. There will be a quiz.
Nice. Uh-oh. Not for us, though, I hope.
No. Okay. This is the quiz.
Okay, so I have 3 things that I remember, too. One of them was, the OS for NVMe and hot plug. What a disaster right now. We're working with NVMe, and it's, way too much fun. Now, you were saying something about Qtips and so forth. Right now, my primary experience is with SATA, but I do know that it's not, on most of the jobs that I've worked with, it is not necessarily the higher Qtips that's faster, even now. Part of it, I believe, is related to the erase block size. I've noticed that if you get a multiple of an erase block size in your Qtips and everything, it tends to make everything faster because of the FTL underneath. I don't know as much as what NVMe is going to do, but I'm pretty sure it's going to tend to be the same thing. And so right now my experience with the drives that I've been playing with, multiple manufacturers' controllers, there is a sensitivity to Qtips and block size, erase block size, not how much,
That's a very good point. I do have a response to that, but do you want to address the Qtips?
Yeah, I mean, block size is a different thing. Yes, it does really matter if you have larger block size, and you're doing a program, you're going to erase the block and it takes longer time. right? And some of those things are getting addressed in firmware, and there are some implementation challenges for
Get a little
this.
closer to the mic.
There are some of them, get taken care in firmware by trying to optimize, how we do some arrays, architecture. There are different ways, when exactly you do arrays, when you're writing or when you're, recycling the block, right? So there are different ways to overcome those challenges, right? I mean, QDepth, the data that we provided is primarily saying that, from the host perspective, most of the activity that happens, on client platforms is all related to lower QDepth. So, why not
That
focus
was another
on
thing
that?
I wanted to talk about. That
Yeah.
was my third thing. But go ahead, finish this one first.
So I think that's what we were trying to show today is that, hey, yes, when we look at SATA, when, this QDepth 32 that we have, for most of our benchmarks is kind of inherited from, SATA days, right? And we still kind of tend to, even on the NVMe SSD, we still tend to kind of focus on what's the QDepth 32 performance. And what we are trying to kind of emphasize here in our presentation today is, you analyze all these, client workload. Really, there is no QDepth 32 there, right? Even though you talk about multi-thread CPUs and all those things, most of the common applications that you look at are all going to be focused on lower QDepth. So why focus on QDepth 32?
And what was your third question?
I was going to say that I noticed, I believe I was detecting that, because I have experience with Windows and Linux, more on Linux. And Linux, I know for SATA, will do whatever QDepth it happens to feel like. And I've seen QDepth of 32 on in Linux. My laptop, my personal laptop runs Linux. My work laptop, I'm required to run Windows, or it would run Linux. And so in there, I do know, again, this is SATA. I haven't looked at the NVMe part of my laptop, but I do know that Linux will give you better than one.
So I agree with you, and philosophically or theoretically, you can say that higher QDepth is always a better user experience, also because of the large files and stuff like that. But again, different operating systems will have a different way of managing how they do the read-write with data, and that's why I'm not saying that higher QDepth is bad. But most of the use cases that we see around Windows, right, is on lower QDepth. Application needing data quickly. Like if you look at video playback traces, they cannot wait for accumulation of data to kind of provide to graphics, right? So some of these applications are really emphasizing on lower QDepth, and I agree with different OSs have different policies. But again, we were trying to address, the most common use cases that we have observed.
Well, I was wondering, you just hit me while you were talking. Has anyone looked at, I don't use Mac stuff much. I have one Mac laptop inherited, but I'm curious. Don't need to answer it. It just makes me think. Maybe I should go play with the Mac I've got and see what kind of QDepth it does.
Yeah, I mean, honestly, we have not done too much study of Mac OSs, right? In future we may do some more analysis
Yeah, it'd be
as we
something
try
to
to
look at.
optimize. Yes.
Yeah.
Well, yeah, but the Mac laptops also, have inherited an awful lot of the what's the name of that company? Anode? Was it? Oh crap! I'm forgetting the name of the company. But their mock kernel and using FreeBSD is actually not an off-the-shelf driver for running NVMe. And so there's a lot of closed box stuff going on inside the Mac. So it'd be very interesting. I'd be interested to see it too. But I know it's just not. They're not exactly using a plain vanilla NVMe driver for that. But would be very curious to see it. Now, to your other point about moving from SATA to NVMe, there are additions into the NVMe 1.4 specification, as well as the NVMe 1.3 specification that were designed for hyperscalers, but could have applications in the client space as well. Mm-hmm. And in particular, deterministic write windows would come in very handy. I/O determinism could come in very handy. Now, it all depends on whether or not the OS manufacturers for clients, laptops in particular, are going to take advantage of that. What would be the cost-benefit ratio for that in a client machine? If, speaking of Mac, that is any indication, I don't think they care, to be honest. I think that the upper layer services are far more interesting for them to get people to buy, iTunes songs and applications than it is to actually make much more efficiency on the hard drive level. But these things do exist inside of the NVMe spec, and I've only listed a couple of them. Whether or not they get implemented or not is a different question.
I think the piece that I would echo there is that because there are some very specialized workloads, so when we talk about something we haven't discussed today, which is something like spec WPC on a workstation, we're seeing a slightly different profile as you would expect for something that's much more compute and data intensive. We are beginning, and we know even our competitors are beginning to look at other opportunities, again, looking at what's available in the NVMe spec to start to specialize around those particular workloads that are more demanding in that environment. I've never personally dug into Mac, right, to see what that looks like, but now that you brought it up, I may have a homework assignment. So
There you go.
I used to be an Apple SE, so
okay.
Yeah, I think to add, NVMe, as I was mentioning earlier, it's a very broad spec. If you look at the kind of features that they offer, but a lot of features are optional, first of all, right? And these features are not really utilized in client space so far.
yes, sir.
Hey, this question is for the panel. Lee mentioned QLC as a technology and it's fitting a certain niche in the value client space. For the panel generically, because I know not all develop QLC SSDs or the discrete memory, but where do you sense the innovations going to maybe improve or expand the use of QLC beyond, just increasing where, over provisioning space, but because of the write intensity and the wear leveling, less endurance. What's the sense on QLC evolution? Like what's left there for innovation?
Good question. I think there's a few opportunities, right? We're already seeing one vendor pair a more specialized type of high performance in front of QLC. In speaking with a number of our partners, we're seeing different dynamic SLC strategies as part of the QLC solution. I think there's an opportunity for innovation that is focused on, I don't want to call it caching or tiering necessarily, but the balance of something small and very fast and lightweight to help mitigate some of the downsides of QLC and still take advantage of the cost and the bit density that QLC has to offer. So I think what we're doing now is really dipping our toe in the water to see how does QLC solve a problem. And as we learn more about it and understand it, and it becomes mature in the industry, that we'll have an opportunity to target it more toward very specific workloads that may be broader than what we envision today. Does that help?
Yeah, very much.
Yeah, I'll add to what Lee mentioned, right? I understand, Dell's point of view, but, Intel has been, calling QLC client SSDs for more than a year, and we are seeing pretty good adoption, primarily due to cost and pricing. And, as far as the innovation goes, yes, if you look at some of our QLC drives that is out in the market, like 660p or H10, there are a lot of innovation, and what you mentioned is mostly around coming up with caching architecture to address some of the performance shortfalls and stuff like that in QLC. But I think the overall goal of bringing the SSD pricing down to an affordable range, I think QLC is really the right strategy to go.
Thanks very much.
Any additional questions?
What's the endurance of QLC?
The interesting thing is the question was, what's the endurance for QLC? QLC was designed to have between 100 and 500 write cycles, programming cycles. Some of the QLC that's been coming out of the factory has been much more impressive, however. We've seen some reports that they've been getting somewhere around 1,000 write cycles. So, and for just to keep things in perspective, we're talking about memory that is cheaper than the thumb drives they're giving away in the expo, right? So, actually getting 1,000 programming cycles on QLC is really impressive. with matching that with some tricks of the protocol, as well as some of the interesting things about putting other additional types of NAND in front of it, it gives us some interesting things to think about in terms of how we have previously considered where storage starts and where it stops. So from the software perspective of being able to write to particular areas, to the much better management and reporting structure of a drive back to the host in NVMe, you can actually get quite a bit of durability from the actual NAND itself by being able to use some of the stuff that's written into the code. We've got 5 minutes left. That's an excellent question, but I think it's also important to note that the stars do have to align. We're not talking about a panacea for the data center or for client here. If somebody were to give me a QLC laptop, for example, I would say no, thank you. Yes, ma'am.
Hello, everyone.
Hello.
So the question is, like you suggested, the higher queue depth is not required. Looks like because 80% of the load was for 1 to 6 queue depth. Isn't it dependent on the storage software, how fast they process it? For example, I'm from VMware, so I know that let's say if I insert a drive, it does depend on how vSAN is able to process each I/O. So your data, so does it have to be dependent on the storage software?
The data was primarily focused on laptop use cases.
Okay.
Yes, for data center and for workstations, high-end desktops, higher queue depth are definitely important. There are applications and there are software that are going to be doing workload at higher queue depth. Yes, but this was kind of focusing. So what has happened is, what we see is, even client SSD that we get today, which are just client specific, not data center or workstation specific, they focus on higher queue depth. What we are saying is that if you look at the workload on laptops, general use client use cases in consumer and corporate segments, the workloads are not very high queue depth focus. So I do agree with you. Higher queue depth is important, and generally when I say improve lower queue depth does not mean sacrifice higher queue depth. Generally, the performance of SSD is going to scale and saturate at certain higher queue depth. So yes, higher queue depth is important for different use cases in data center and enterprise.
Oh, okay, and one more question.
That's good, because that's all we got left time for you. So one more question, please.
Okay, one question. Can I? Okay.
Yeah.
Okay, so this workload was sequential or random, or it doesn't depend on when you say 80% of was falling under 1 to 6 queue depth?
So when we talk about these specific workload that we discussed today, they are not really, it's like a mixed workload. So you're going to see mix of sequential and randoms. You're going to see mix of several queue depths. What we were saying is, like, if you look at one of the traces that we have captured, let's say Mobile Mark 14. What Mobile Mark 14 does, it is like a standard, client use case. It emulates the standard client use case throughout the day. So it will run certain application. It will open up, Microsoft Office tools. It will go into standby for some amount of time. So it is just emulating the full client use case, and that's the trace we have captured. So you can get mix of sequentials, randoms, and different queue depths.
Thank you very much.
Okay.
Thank you very much for coming this morning. I really appreciate all the attendance and the fantastic questions. Thank you so much. And I want to thank our panelists for being flexible. Sometimes the things don't go always as planned, Mr. Jain. And I hope you enjoy the rest of your Flash Memory Summit. Thank you.
Thank you.